Bismillahirrahmanirrahim. We are starting the new session, and if you remember, we finished at this step. So I am continuing from this step onward. So it becomes 1 upon minus 4. Then denominator will become minus 4 and minus minus plus 25 nines are 225. Then it is important to focus on this step now. In numerator, this bracket will be applied on sign. So if you remember, d represents the derivative with respect to x, partial derivative with respect to x, and d dash always represents the partial derivative with respect to y. So d of sin x means derivative with respect to x. So derivative of sin is cos 2x plus 3y into 2. The derivative of angle is 2 with respect to x. Then minus 5, this minus 5, and d dash means derivative with respect to y. So again cos 2x plus 3y, and now is 3 because the derivative of angle with respect to y will be 3. So now if I simplify, then it will become 225 minus 4 is 221. So 1 upon minus 4, denominator becomes 221. Then in numerator I have 2 cos 2x plus 3y minus 3 5s are 15 cos 2x plus 3y. And it is possible to add both these values. So we can finally write that 1 upon minus 4, in numerator minus 15 plus 2 is minus 13 cos 2x plus 3y upon 221. This will be the final answer of this example number 1. So remember what we need to do. I am explaining the whole example again because I did last few steps in this current session and most of the steps will be done in previous session. So this example is pertain to method number 2. Method number 2 deals with linear sine and linear cos. Linear sine and linear cos. Method 2 deals with this. It means when on right hand side we have a linear sine or linear cos, then this method will be applied for calculating a particular integral. So I write in this way, and then this gives me the values of a and b. Again compare this angle with this angle, so we will find the value of a and b, and remember a means the value of d and b means the value of d dash. So but now in this method 2 we just allow to substitute the quadratic values, that is d square, d dash square and d into d dash. Only 3 quadratic values can be replaced. D square will always be replaced by minus a square, d dash square will be replaced by minus b square, and d into d dash if appears then it can be replaced with minus ab. Remember that this minus is separate from a or b or this. This square is not on minus. This square is only on the value of a. Similar thing here, square is only on b, not on minus. This is a major mistake done by students. Then they put like in this way, minus a whole square. This is not minus a whole square, this is minus a square. So now we substituted these values. I substituted d square and d dash square, and then simplify as much as you can. Then you will find that you have the now linear d and linear d dash. So it is mandatory to make them quadratic. So just rationalize them. So I rationalize, and linear d and d dash becomes quadratic. So now we are allowed to substitute these values. So in denominator we substituted these values. But in numerator d means derivative with respect to x. So I applied derivative with respect to x, and d dash means derivative with respect to y. So I applied this in this way. So this is the way to solve the example by utilizing method number 2. So let's solve another example. Let me solve one more example at least. Example number 2. Example number 2. Partial 2z over partial x square minus 2 partial 2z over partial x partial y plus partial 2z over partial y square is equal to cos of x plus y. I am trying to make this example different from this example. So in operator D form, this will be in this way. Then for finding the particular integral, Zt will be equal to 1 upon d square minus 2d dash plus d dash square cos of x plus y. Now here a is equal to 1, b is equal to 1 means this is the value of d and this is the value of d dash. So now we are substituting z equal to 1 upon d square will be replaced by minus a square means minus 1 square. D dash square will be replaced by minus b square means minus 1 square, and d into d dash will be replaced by minus ad means minus 1 into 1. So it means it's become minus 1 square minus 2 minus 1 into 1 plus minus 1 square cos of x plus y. So it become 1 upon minus 1 plus 2 minus 1. It means denominator is 0. So the second case, in this scenario, since denominator was not 0, so this is the final answer. But it is possible that we have the denominator become 0 when we substituted these values. So remember, this idea applies here will be the same as we did in higher order OD, that whenever denominator becomes 0, we need to differentiate the denominator. So now I am differentiating. So writing x, then 1 over d square means 2d minus 2d dash. Since now both d and d dash are linear, so we need to rationalize again. So x upon I took 2 common, So this become d plus d dash, d minus d dash. So rationalizing with d plus d dash cos x plus 1. So what happened? This become x upon 2. Denominator become d square minus d dash square. Numerator become d plus d dash of cos x plus 1. So let me write one more step here. X upon 2, d square is minus a square minus b square. Look, again the value of the denominator is 0. Again the value of the denominator is 0. 2d minus 2d dash. I substituted d square is minus a square. This minus is this one, and d dash square is minus b square. So this minus multiplying with this minus becomes 0. So that is why what you need to do again is to differentiate it again. So it becomes x square d plus d dash upon 2d. D square will become 2d cos of x plus y. And now we have the final answer as x square upon 2 d plus d dash. Now it is better to write this step not here but in this place, so you have the clear vision of this step. So now I am writing the next step here, that is Zp is equal to x square by 4. 2 multiplied by 2 is 4, and then we have d plus d dash upon d cos of x plus y. Now we only have a linear d in denominator, and if you remember I told you that 1 upon d means integral. So this is x square by 4 d plus d dash into integral of cos x plus y dx. Means integrate this thing with respect to x, partial derivative. So it means x square by 4 d plus d dash, and it is sine x plus y. The derivative of cos is sine. And now x square by 4, derivative of sine is cos x plus y, and derivative of sine is cos x plus y. So it becomes x square by 4 into 2 cos x plus y. 2 cancel with 2, so it is x square by 2 cos x plus y. So what is the difference in both these examples? In example 1 we focused on this point that when denominator is non-zero, then that will be the answer. But if denominator is 0, what we tried again and again in ODE, that you need to differentiate. So I differentiated and then substitute the value. If again it is the denominator is 0, then you need to again differentiate it. And what the other thing is important in this example, that if you have a linear d, then you can make it quadratic, but the other way around is to use as integral. The same thing we discussed in higher order ODE as well. So now let me give you one more example of this to highlight one more point. have an example like this. Example number 3. Partial 2z over partial x square minus 2 partial 2z over partial x partial y plus partial 2z over partial y square is equal to sine x. What is the difference in example 2 and 3? The major difference is that how you will compare this angle with general this angle. So remember, if you do not have the value of y in the angle, it means b is equal to 0. Because we can write this as sine x plus 0y. Or other way around, if you have, let's say, sine y, it means the value of a is 0, because we can write 0 into x plus y. So that is why I am doing this example, to give you an idea about the values, that how you will consider the values. So for Zp, this is equal to 1 upon d square minus 2dd dash plus d dash square, and this is sine x plus 0y. So where a is equal to 1 means b, and b is equal to 0 means b dash. So how we will substitute these values? We said that Zp is equal to 1 upon d square means minus a square minus 2d into d dash means minus 1 into 0 and plus minus 0 square, and this is sine x plus 0y. So it becomes 1 over minus 1 minus 0 plus 0, and this is sine x, means we simple have minus sine x. So this is the way, if you do not have both x and y in the angle, then it means if x is there, it means the value of b is 0, and if only y is there, it means the value of a is 0. Now we are going to some other kinds of example. Means now our focus will be on those examples where we do not have a linear sine or cos. If you remember, we did the same thing in ODs as well, that if we not have the linear sine and linear cos, then what will be the way out to make it a possible way out for those kinds of questions. Let me give you an idea about this example number 4. Let's say we have partial 2z over partial x square minus partial 2z over partial x partial y equal to sine x cos 2y. I have linear sine and linear cos, but in product form. But method 2 does not deal with product. So there are two possibilities here. Possibility number 1, if you know there is a formula sin alpha into cos beta, product to some formula of trigonometry, means 1 by 2 sin alpha plus beta plus sin alpha minus beta. We can use this formula. Or becomes, this will transform our question in addition form. Sin x into cos 2y will be equal to 1 upon 2 sin x plus 2y plus sin x minus 2y. If we substitute this value, it means our question will lie again in this form, the order form. This is the one way to deal it with. The other way is this one. This is the one way. The second way is sin x into cos 2y is equal to, I am writing the exponential value of sin x and cos 2y. What happens if we substitute these values? The question will transform into method 1. How? Look, denominator multiplied with denominator becomes 4 iota. E power iota is multiplied by e power iota 2y. So it is e power iota x plus iota 2y. Then plus e power iota x minus iota 2y. Then minus e power minus iota x plus iota 2y. And finally minus iota x minus iota 2. So you will have 4 terms of exponential on the right hand side. Means method 1 will be applied on 4 times. This is the second way around to solve this kind of question. And even though that we need to make more calculation in this way as compared to in this way, but still I prefer to go for this method because this method is helpful for all kinds of terms. For all kinds of terms. Let's say we do not have this term here, I have this term here. Sine hyperbolic square x, sine hyperbolic square x. Even I do have only sine hyperbolic x. Even though it is linear, but since it is hyperbolic, so method 2 is not applicable. Then how will we proceed? If I write in this place e power x plus minus e power minus x upon 2, then again method 2, this technique will be applied. Method 1 will be applied. Let's say we do not have this term, we have a term like this one. Sine hyperbolic x minus y into cos x plus y. One term is from hyperbolic, one term is from circular. Still method 2 is not applicable directly. But if I substituted these values like in this one, then again it is possible to solve. Let's say we have another kind of term. Let's say I write on right hand side cos cube x plus y. Still method 2 is not applicable because this cos is not linear. So how we can treat? I write e power iota x plus y plus e power minus iota x plus y upon 2. What is this? This is the value of cos x plus y. Then we have a cube, so make it cube. What happened next? If I open this bracket, I have 4 terms in the numerator. 4 4 terms of exponential. Means in denominator we have 8, in numerator we have e power 3 iota x plus y plus e power minus 3 iota x plus y, then plus 3 e power 2 iota minus iota x plus y and plus 3 e power minus iota x plus 1. Again, method 1 is applicable 4 times. So remember that the same thing we discussed in higher order ODE as well, that if you have a linear circular linear sine linear cos, then this method is okay to apply. But if we do not have a linear sine or linear cos, then the way out is to substitute the exponential value of sine or cos, whether they are in product form or non-linear form. Just substitute the value, simplify that one, and you will see that your question is automatically transformed in method 1 category. And then apply method 1, which is the simplest method in all methods. So my advice to you is to try these 5 questions as practice problems of combined method 1 and 2. First of all, I write it here sine x into cos 2y. This is on number 1 is, then in second scenario, replace right hand side with cos cube x plus y. Then in third scenario, replace right hand side is with sine hyperbolic x plus y. Then in fourth scenario, replace this one with sine hyperbolic x into cos y. And then in fifth scenario, replace with this sine hyperbolic x cos hyperbolic y. So you will find that you have enough practice for this method number 1. So practice problems for method 1 and 2 combined. This will give you combined practice of method 1 and method 2. So as far as this session is concerned, I am concluding this session. We have finished with method 1 and method 2 in these sessions of higher order linear homogeneous PDEs, and inshallah from the next session we will start with method 3 of the linear homogeneous higher order PDE. So it's goodbye from now.